Hey guys, welcome to the 7.3 video. Today we're talking about solving equations using multiplication or division. Alright, so I thought I'd start us off on this problem, and it just says, how would you find the value of x given this figure, these two, and that? Well, so they're telling us the area is 48 feet squared, right? So this side is 6, this side is, well, is x, right? He's unknown. We're trying to figure out what x is. So I think, if it were me, I'd say, well, I know how to find area, right? Area is the length times the width for a rectangle. And, so the length times width is going to equal area. Well, I know area is 48, so this length, which is unknown, times the width, which is 6, is 48. So isn't it really like saying some number times the known 6 is equal to 48? Otherwise known as, hey, what times 6 gets us 48? And I think we all know that. It's 8, right? So x is equal to 8 feet. And so that's kind of like the first thing I wanted to show you, because that's really more or less what we're doing today. Pretty easy. I think you'll catch on. So the first thing I wanted to cover is recover is inverse operations, which is what we learned in the last lesson. So remember, inverse means opposite, right? Opposite operation. So I want you to try this, and I want you to figure out, okay, what's the operations multiply? What's the opposite? So on and so forth. Pause the video, but play it when you're done and see if you get the same answers. Okay, did your answers line up with mine? I hope so. Opposite of multiplication is division, opposite of addition is subtraction, opposite of subtraction is addition, and the opposite of division is multiplication. If you know that, you're good for today. One other thing before we move on, and you might be saying, well, why would we do this? And I promise it'll make sense. But we want to write some things as fractions. Okay, so if I said write 7 as a fraction, what would we do? Well, we need to remember that 7 is always actually the fraction 7 over invisible 1. That easy, right? So what about negative 4 as a fraction? Well, we know that negative 4 is really negative 4 over 1. That's another thing. If you know, you're going to be good for today. I think everybody's probably going to be fine on that. All right, so let's solve some equations with multiplication. So first one, we've got some unknown. When you divide it by 4, because right, remember fraction bars mean division, you get 9. So what divided by 4 is 9? Now, these are pretty easy. This first one, at least, we can say, well, I think 36 divided by 4 is 9. It's true. But here's the method to solving it. Again, we ask ourselves, is the variable by itself? Well, no. He's being divided by a 4. So he's being divided by 4. What's the inverse of division? Multiplication. So how do we get the variable by itself? We multiply by 4. And this is why we did that little fraction thing before. This, w over 4, is really a fraction. And we know we need to multiply fractions by other fractions. And so I'm going to multiply by 4, but I'm going to use it in the form of 4 over 1. And remember, whatever we do to one side, we have to do to the other. So the other side is not a fraction. So I'm just going to write, instead of 4 over 1, just regular 4. Again, I'm still doing the same thing to both sides. This just looks a little different than that, but it's the same. Okay, why did I use a fraction? Because I can cross cancel, right? What's a 4 on top of one fraction times a 4 in the denominator of another one? Well, they become 1 over 1. And so, well, this looks kind of complicated, but really think about it. If these cancel each other out, isn't this 1 times w? Yeah. Over 1 times 1, which is 1. And we know that anything over 1 is just itself. So really what happened is we canceled everything and we're left with the variable w. And then on this side, that's super easy. 9 times 4, 36. How can we check our answer? Well, you just take the 36, plug them back in there to the original. So is 36 divided by 4 equal to 9? Well, what's 36 divided by 4? 9. Does 9 equal 9? Yeah. Right? How about this one? Well, is the variable by itself? No. Being divided by 3. What's the opposite or inverse of division? Multiplication. So we're going to multiply by 3, but on this side we're going to make it a 3 over what? 3 over 1, so we can do a little cross cancel. On this side we got to multiply just by regular 3. Okay? And so remember, what happens is, yeah, it becomes a 1 and a 1, and we could do x times 1 over 1 times 1, but we remember that the reason we multiplied by 3 was to get rid of everything but the x anyway, so I'm just going to write x equals, what's 3 times 1.2? Well, that would be 3.6, okay? And we can check our answer here by saying, okay, well, decimals, maybe I'm not totally sure. We'll plug that guy in. If we did it correctly, then 1.2 should equal 3.6 divided by 3. Okay, well, what's 3.6 divided by 3? Well, take your 3.6, if you really want to check it the long way, and do that. Divide by 3. Goes in there once. Move your decimal up. 3 goes into 6 twice. Get a 6, and done. So 1.2. Should it equal 1.2? Yeah, that equals 1.2. So what does that mean? It means our answer of 3.6 was correct. You might be looking at that and making that face, but I promise it's going to be super easy. Okay, so we're going to solve 3 halves x equals 12, and that's actually super easy. So to solve 3 halves x equals 12, we need to understand what the multiplicative inverse, okay, big word, multiplicative inverse. Sometimes we just call it the reciprocal though, okay? Those two are the same. Multiplicative inverse, multiplicative inverse. Call it the reciprocal, it's fine. What is the multiplicative inverse or the reciprocal of 3 over 2? It is 2 over 3. And 2 over 3, how, Mr. Strubar, how in the world did you get that? Well, I mean, let's keep going. Maybe you can figure it out, okay? The multiplicative inverse, or reciprocal, is found by flipping the numerator and denominator. It's that easy, okay? So if we go up here, what's the multiplicative inverse of 3 over 2? 2 over 3. It literally moved the 3 down, and I moved the 2 up. That's all you have to do. Okay, so then we use that by multiplying the multiplicative inverse to solve our equation. So this is that equation we're going to solve. What is the multiplicative or inverse or just reciprocal of 3 over 2? 2 over 3. So what we're going to multiply by is 2 over 3. And maybe you're now seeing why that makes some sense. Because, look, can I cross cancel those 2's? Yeah. Can I cross cancel those 3's? Yes. And I'm really just left with 1x over 1, which is just what? It's x. That's why we did it, right? Oh, wrong color. I'll use that color. It's x. That's all. Why did we multiply by that 2 over 3? To get rid of the 3 over 2, so we are just left with x. Again, we're trying to get the variable by itself, and now he is. Now, got to do the same thing to the other side. So, this side we multiply by 2 over 3. We have to multiply this side by 2 over 3. But you might be saying, wait, I thought we only multiply fractions by fractions. Ah, we do. So, I'm going to make that 12 into what? 12 over 1. Oh, all of a sudden it's a fraction. Didn't change the value, right? But it's a fraction. So, now, let's do some more cross-canceling. 3 and the 12. Well, 3 is the greatest common factor, or is, 3 is a factor of 12, right? Okay, so, and of 3. So, if I take a 3 out of a 3, I'm left with a 1. If I divide 12 by 3, I'm left with a 4. All right? Now, I can't cross-cancel 1 and 2, so let's just multiply. 4 times 2 is what? 8. 1 times 1 is what? It's 1. What's 8 over 1? It's just really 8. Our answer is 8. Okay? Now, how are we certain we got the right answer? Well, plug it in. 3 over 2, and 3 over 2x means 3 over 2 times x, so 3 over 2 times our answer of 8, and I'll make that 8 over 1, should equal the 12 we began with. So, okay, well, you can cross cancel if you want, and we got 2 and 8, so it becomes a 1 and a 4, and then we got 3 times 4, right, which is 12 over 1. Is 12 over 1 the same as 12? Yeah, it is. So, confirms our answer, 8 was the correct answer. Alright, so I want you to pause the video and try this one. Play it when you're done. Alright, multiplicative inverse. Got to get rid of that 2/5 by multiplying by the inverse, which is 5 over 2. Now, sometimes I like to squeeze it in right there, but you don't have to. If you want to write it over here, I know the m is kind of in between. It doesn't matter. It's fine. Don't panic. Alright, so 5's cross-cancel to 1's, 2's cross-cancel to 1's, and I'm really just left with m. Multiply the other side by 5 over 2. I'm going to make the 40 into a 40 over 1, so I'm multiplying fractions by fractions, right? Okay, 2 and 40, I can cross-cancel those into a 1 and a 20. And 5 times 20 is 100 over 1, which is just 100. So I think our answer is 100, right? Well, what is 2/5 times 100? 2/5 of 100 is 40. So we did it right. 100's our answer. All right, so we've solved with multiplication. Now let's solve with division, okay? And so we're going to solve this first one with division. Okay, again, why is the variable not by himself? Well, 6y, what does that mean? It means 6 times y, right? So to get rid of multiplication, I got to do what? Divide, right? By what? Well, 6. If it's multiplying by 6, that's the problem. We divide by 6 to get rid of the problem. And what happens is 6y over 6, guess what? Cancel, cancel. You're left with y. It's that easy. And what's 66 divided by 6? 11. Check your work. If you plug 11 in there for y, what's 6 times 11? 66. All right, pause the video and give that one a shot. All right, so first question. Variable by itself? No. Why? Because he's being multiplied by 13, right? So how do you get rid of a multiply by 13? You divide by 13 on that side and that side, okay? And those cancel. And you might be saying 104 divided by 13, I don't know. Well, it's probably a good one to know. Okay, well, we know 13 times 10 would be 130, so our answer can't be quite 10. It's got to be a little less. And if you end up, do the division, you guys know how to do that, right? You get 8. That is your answer, okay? What that means is 13 times 8 is 104. All right, so some other equations you might encounter might look like this. 12 equals m divided by 4. Okay, well, guess what? That's really the same as if you saw m over 4. It means the same thing, right? We would multiply by 4 over 1 and cancel, and then multiply by 4, and our answer would be 48 equals m. Okay, so don't get freaked out by just something that looks a little different. How about this one? Okay, so 3 times a number divided by 4 is 12. Okay, well, here's the thing. Here's something we really need to remember. Anything that directly touches the variable should, in most cases, be dealt with last. Okay, so here's the variable. He's being multiplied by a 3. He's being divided by a 4. What we need to do is get rid of the 3 last. So what that means is we get rid of the divide by 4 first. How? Well, we multiply by 4, okay? So sometimes we'll see it like this. You can do that and say, well, okay, it's multiplied by 4. Cancel those out. And multiply the other side by 4. Whatever you do to one side, you have to do to another, right? And so 3x, those cancel each other, equals what? 48. And then we can deal with the 3. Divide by 3, divide by 3, and x ends up equaling what? 16. Now, if you don't like this little thing here, sometimes what I'll do is I'll rewrite problems like this as 3x. Since 3x is being divided by 4, I can write it like that if I want, and then solve it like that. And so, again, whatever touches the variable we want to deal with last, so multiply by 4 over 1 to get rid of those, and multiply by 4 there, and you'll get the same answer. We're still left with 3x over 1, which is 3x, right, equals 48, and you just still divide by 3 and divide by 3, and you still get 16. It's the same answer. A couple different ways to solve the same problem and get the same answer. Alright guys, so that's all I have for you. Thanks for sticking with a little bit longer video. Hope it was helpful, and I will see you in class.